So this is the way I like to see this, the problem. It's not something we have a predefined order. At the end, you will find a way to search things, but from the very beginning, it can be anywhere, so you have to iterate wherever you start from. Let's start from MySQL, okay? What's going on? Check show process list. Look for running queries. That's the pretty easy one. And the very common one, to be honest. Sometimes we understand that long-running query is slow, but sometimes a single query that takes an hour and runs once a day, who cares about that? That is something that have to keep in mind. If the problem is not the query, maybe the problem is in the V. Okay, check the engineering status. What's going on? Open transactions. Sometimes, especially with some frameworks like Java, stuff like that, transactions become, not auto-commit enabled, so let people keep transactions open. They don't realize they have to commit or roll back. Our history list length grows like a crazy thing, and everything starts sucking, and we don't know why. Okay, open transactions. Also, semaphore contention. That's a little bit harder to understand. Actually, if I have to say, I don't fully understand. I understand the contention. I don't fully understand what each of the semaphores means and how to solve all of them. But that can give you a hint of what's going on. So one thing we can think for an approach is try to get real response time of queries. One of them is, of course, observing the slow query log. But the other one is, okay, I'm going to deploy a query in production. How long it will take? Okay, script it. Okay? You write the code, you get a start time. Some code I say a bash script, something very, very simple. Put a timestamp, run the query, get the finish time, and you will get a sense of how much that query will impact. Of course, and this is best practice, always get an execution plan of the query, okay? Write the query, check the execution plan, and try to improve that even before you deploy that. Capture queries, I say, show for process list, parse slow query log with PT Query Digest. Are you familiar with the tool? Yeah, PT Query Digest. If not, start using that because it will save you a lot of time. As said, analyze query. You have several ways to do that. Of course, it's plain extended, which in Percona server is executed by default. Even you don't put extended, it will run with extended. We will show you not only the execution plan, but also how the optimizer is rewriting the query for executing. And actually, it might change during the execution time, but that's another story. Explain format JSON. This is very handy. If you didn't use that yet, test it. It could be a little bit overwhelming because it throws a lot of information, but will help you a lot with those moments where you don't understand why it's picking one index instead of the other. You will see stuff like weights, So it's a pretty useful tool that comes with MySQL from 5.7, I think. And finally, get the handler statistics. Are you familiar with this counter? Handler statistic? Okay. Well, MySQL exposed through show status variables a set of counters that start with handler. Handler come next something, handler come, It will show you, for example, if your queries are doing full table scans, if your queries are using joins properly. There's a lot of metrics. I don't know, maybe over 20 metrics exposed through that handler counter. And it's super easy because it's a session thing. So you can, get your query, flash status, run the query, show status like handler, and you will see what your query is doing, how many rows it's reading, how many rows it's returning, everything. So it's pretty useful to understand if your query is executing properly and find a way to, it's good to understand if you need to add indexes, stuff like that. Review your schema. this is a very hot topic because with some frameworks, especially those that you run an application, Magento, for example, that creates the schema for you, and you will be happy with that until you throw some, some concurrency, and you will start to suffer. Of course, just create table. You have to know if you are using the proper engine. There are a lot of them. I will only focus on these two because they are more popular. Show indexes from table. That is to help you optimizing your queries. And then we move to the next moving part of the system, which is the hardware. Okay? You see performance problems. Okay, is it inside MySQL or not? Let's start from top. Top is in every Linux distribution. It's a pretty useful tool. The information that it provides can be, what's the pointer here? This one? Okay, yeah. So the information that TOPS provides can be or cannot be useful depending on the context, as said. But let's say this is a test I did some time ago. We have that MySQL is consuming 100% of CPU. We may have more than one core, so it's not a big deal. 67% of the RAM, it says nothing. But then we have this bad guy here. There you go. I/O weight is so high. 40% of your time is spent waiting for I/O operations. That means that you have a problem with your storage. What the problem is, okay, it's not going to be seen here, but you see that you are consuming 40% of your time waiting for operations. That's not good at all, okay? So top is very handy. It's there by default. Use it. I use that all the time. There are better ways now. I heard about a tool. I didn't use that yet. It's called something like ATOP, that then you can split I/O consumption per process. We have here only a general view of the I/O. Maybe it's not MySQL what is causing the I/O problem. Maybe you have something running on the background, a backup. So this tool, I think it's iTop. I don't remember, but it's pretty useful to know that. Otherwise, you have, IOStat, stuff like that can help you. But iTop? EOTop, okay. There you go. Swap activity in this case is nothing, so it's good. But swap can be a huge problem in databases because, when you start swapping things, applications stop working. Okay, another source of problems, configurations. Operation system, as said, CPU, memory, and I/O. We will get there in few slides. MySQL configurations, the configuration file. So for these two main problems, we have Percona toolkit to the rescue, I call. How many of you are familiar with the Percona toolkit? Okay. It's a free tool for those who doesn't know it. Use it because it will save you a lot of time doing things. And I will show some of very small samples that I use in my day-to-day work. PT summary and PT MySQL summary. These two tools will give you, in a single shot, tons of information that will help you with this. We will get there later. Okay, for OS configuration, swappiness. The default in common in most of distributions, let's say CentOS, Red Hat, Ubuntu, Debian, the default is 60. It's super high, super conservative. This means swappiness is the value that instructs the operation system to set the tendency to move pages from memory to disk, okay? So whenever the memory starts to suffer in some pressure, the operation system will release memory by moving pages from memory to disk. 60 is super high for our day, for our work. And you don't want your database to start swapping things because it's painful, okay? Then I/O schedulers. Again, default for most of distribution, if not all of them, is CFQ. CFQ is a disk scheduler, which is very good for machines that are running multiple applications. Not our case. We normally use a dedicated server for MySQL. So again, this is not good. CFQ basically sets portion of time for each process running in the server. It assigns time to use the I/O queue. So there is no priority. All the process has the same level of access to I/O, which is not good. Even top, for example. CPU governors, okay? By default, is power saving. This means that your CPU will not run at its best by default. Okay? As said, none of them are good for DB workload. It may work for other type of things, but believe me, not for DBO. And changing them makes a huge difference. In PT summary, you have all of this in one shot. Okay? It's reported within the first 50 lines of the report, so you have seen them in a single shot. By the way, I just sent the whole presentation to Santiago, so it will be uploaded somewhere. And if you don't want to take pictures, just give me your email and I will mail you the presentation. It's fine, I don't mind if you take pictures, but I can give you the whole presentation. I don't mind with that. Finally, NUMA. NUMA is I don't know how to call that. It's a technique to distribute memory between what is called CPU nodes. With modern hardware, we have each physical CPU. I'm not talking about cores, but CPUs. Each physical CPU is called a node in Linux, and I thought Windows has something like that. So when you have more than one physical CPU, the memory allocator will try to, by default, try to allocate memory all for the first processor. Once the processor is done, I mean, the whole available for that processor is done, it starts to the second one. So whenever you have a process that needs to access memory here, but the process is running here, you have some overhead, you know. NUMA has a this is done by NUMA, no? The allocator, the allocation of memory. The default is not interleave, which is doing what I just explained. If you change that to interleave, all the memory will be distributed evenly, whole same amount of memory going to each processor. So it's unlikely, or it put down the amount of memory dedicated to one processor. The main problem is that when you have a full processor, aside of what is assigning here, if a memory needs to enter here, a memory page needs to enter here, it will swap that memory to disk. Okay, so it's not that. So only the process running here has to increase to use memory here. It will swap that page, which of course is a very costly operation. So by default, this is the default behavior. Nowadays, and especially with latest versions of Percona server, I'm not sure about my MySQL community, we are changing the memory allocator to JMalloc, which is a very good one and makes a way better work than that. But something to keep in mind is NUMA. There are some papers from Jeremy from Twitter, and now he's in Google, about how the swappiness problem with NUMA is happening. So something to keep in mind. Okay, MySQL configurations. InnoDB variables, okay? InnoDB buffer pool. Actually, it's InnoDB buffer pool size. I have to correct that. How much memory you dedicate to InnoDB pages. This is the most important buffer because everything in InnoDB happens in memory, okay? So whenever InnoDB needs to check a page, read or write a page, it has to take it from this, put in memory, and do whatever operations it has to. Of course, the bigger is the better here. And there is a very old rule that you might probably hear about, that you have to use up to 80% of your memory to dedicate that to InnoDB. Okay, that's good for servers with, let's say, 8 gigs of RAM. Nowadays, with 500 gigs of RAM, if you put only 80%, you will be wasting 100 gigs of RAM. So it's not like that. Just use as much as you can. And of course, as much as you can, as long as your data set is smaller than memory. If you have a 32 gigs of data set and you have 400 gigs of RAM, who cares? 100 gig to the buffer pool and everything goes to memory. That's it. InnoDB log file size. This is it may impact performance in some ways that you don't expect. Number one, recovery time. If you have a crash, either you have very long crash recovery because you have a very long file size, or if you don't have a crash but you have a very small file size, you will start pushing on InnoDB to move the dirty buffer and do segments and whatever to the redo log files all the times, and you will be creating a bottleneck, an artificial bottleneck, because of these files are not well sized. The other point is with the checkpoint of the buffer pool, the checkpoint size and history things. That's a little bit more complex, but rule of thumb is measure how many changes are you doing, let's say per minute, and correlate that to 1 hour and size the files to allocate 1 hour of changes. That's pretty much it. The math are very simple. I can show you later. I don't know if I have it here, but I can show you. Flash log at transaction commit. Anyone familiar with this variable? Okay. This variable instructs InnoDB when to force a commit, to flash changes to disk during commit times. By default, it says that every one you run a commit, InnoDB will force a flash to disk, which is good for consistency, but it's not good for performance. So here you have a drawback. What you decide. You prefer to have consistency, so in case of a crash, you are sure that your data is there. Or if you can afford some data losing, normally up to 1 second of data, then changing this variable will improve a lot the performance, because you will decrease the amount of operations to disk. Flash method. By default is none. By default, depending on the operation system, is OSync, which is crappy, unless you are using a very old file system like ext3. Nowadays, with newer file systems and modern, file system like XFS and ext3.4, this is not Windows compatible. So what I'm saying, ODirect is the way to go. In the other one, CFS, we have to use ODsync because CFS is not very popular yet, but keep an eye on that because it's coming. And then we have these two that I found that many people is not completely understanding what they do, and with the arrival and the usage of SSDs disk, this solid disk that can afford a lot of write operations in parallel and stuff like that. People were, okay, yeah, let's increase that. Okay, no, you shouldn't. These two instruct to InnoDB to say how many pages will flash to disk whenever it's needed, every second, and then if this flashing is not effective because you are writing too much, there is a loop every 10 seconds that will grow up the I/O capacity up to certain limit that you set with this. By default, it looks very conservative, but believe me, defaults works in most of environments. You don't really need to increase these two. And sometimes I find, especially, I found this becoming a problem in replication environments. People setting these two variables like crazy, 4K for I/O capacity and 10K for capacity max, which is huge, and start to suffering problems with replicas. Because, row-based replication, every row creates a commit, everything is flushed for every row, so replicas start to have problems with that. We put that in defaults, and everything start working like a charm. So after that, for InnoDB, is to fine-tuning. There are, I don't know, 50, 70 variables that you can change. Believe me, with these 5, you will cover, I don't know, maybe 90% of the cases. And then we have Myosin variables. Are you still using Myosin? No. If you care about your data, move away from that. I'm joking, but there are still some use cases, but most of them, they become a really good thing to keep using. Actually, I don't know if you attend the Fred talk about group replication. InnoDB is the future for us. So, in latest version, they are deprecating even for the data dictionary, so for the system database. So, still, some people use that. Variables for Myosin, key buffer size. That's it. This is the analog buffer, like the buffer pool. Here we have the key buffer size. It just stores the indexes in memory, and it's the way that the Myosin works. Not too much to do aside from that. Query cache, a big point of contention. Just turn it off. Actually, in MySQL 8, they completely turn it off by default. Up to with first releases of MySQL 8, they put the query cache size in 0, but they didn't change the query cache variable, so by default it was enabled. And we found that there is still overhead in the query cache mutex whenever it's enabled, even if you are not assigning memory to that. So there is a call that is still working, so put them off in the configuration file. The problem is that it requires a restart, but it is what it is. Per thread buffers. There are many of them. Basically, these are the buffers that are allocated per each thread, 10 table size, sort buffer size, I don't know, some of them, join buffer size. There are plenty of them. The only 2 that I would consider tuning are these 2, 10 table size and max heap table size. They should be the same, and the defaults are a bit conservative. I think there are in 16 megabyte, which is a little bit small, but I don't recommend to go beyond 64 or 128 megs in any of them. If you need more than that, either you are not doing your queries properly, or you have to tune them on a per session basis. If you want to run a huge query that requires a big 10 table, okay, set by session, increase the 10 table size, and you will be fine. But don't do that globally, because these are allocated per thread. So sometimes you have, I don't know, 100 connections open, and this is interesting because I'm not talking about threads running, connections open, because every connection will allocate the buffer, and even after the query is done, the buffers will remain allocated. So 100 connections open will allocate a lot of memory. The others just keep the default. They work for most of the cases. It's very rare to configure them. And all of these things are shown in PT MySQL summary in one shot. You can run show status, but the output is like 200 rows, and it's hard to read. But if you want to suffer, who am I to tell you don't? So run show status. Okay, sample of PT summary. PT MySQL summary, sorry. Things like data directory, socket, MySQL version, how many databases, where is data. I mean, it only summarizes and presents the data, the status data in a lovely manner. here you have something from the InnoDB. Interesting things. We are using flash log and transaction commit at 1. This is not good, as said. Flash method is empty, means that we are using the default ODsync, which is not good. Well, 128 megs of buffer pool, that's not good either. So I should, well, I have to recognize this is on a VM on my machine. I will not put more memory in a VM. But you had this in one shot. If you read this through show status or show global status, or show global variable, sorry, you will see tons of information. And sometimes it's not easy to read. When you have a, let's say, 200 gigs buffer pool, you will see a huge number because it's everything set in, bytes only. It's not human readable. So, pretty summary. Again, iterate the process. Sometimes you fix here, but then you realize the problem might be here. And when you fix everything, you start to see new problems. So go over and over. Best practices. OK, recommendations. Monitor your systems. Pick one tool. I don't have any preference. Of course, I have to say PMM because it's Percona thing, but Vivid Cortex works very well. Datadog too. And try to read patterns all the time. You follow the pattern. You will see with graphics it's so easy. When you start to see, an increase in CPU utilization, memory, swapping, whatever. Slow query low. One of the things we do in Percona, especially when auditing customer system, is to capture not only slow queries, because slow query is a term that can mean different things for different persons. So what I do, I start from the very bottom. Put long query time in 0, capture 1 gigabyte or 1 hour of queries, and then turn it down or turn it back to whatever it was. Start analysis there, because there you will see what are the most impacting queries, not the slowest. Again, as said, if you have a query that runs in 100 milliseconds, you say, OK, good, increase concurrency, and you suddenly have 80% of your time is spent by one query. Fix that, and you will see the results. One interesting thing that is only, I'm not sure if MySQL is going to finally port it or not, but there is a variable called log slow verbosity, which can increase the metadata that is written to the slow query log, providing statistics, some metrics, stuff, very interesting things to understand what the query is doing. For example, full table scans, how many rows are returning, how many rows are reading. I don't know if they are doing joins. It's a bunch of things. Again, iterate the process. Query review is something you should do on a regular basis, once a month, once every 2 months, but do it. Not everyone takes the time to test the query before pushing to production. Okay, I write the query, it works, go to production. And happens more often than you think. And when in trouble, okay, like I don't know what's going on, Pitstock is a very, very good tool for forensic work, because it will take up, let's say, a picture, snapshot of the whole system. What is going on in the memory, what is going on with the disk, what is going on with MySQL, what is going on with the queries. You have, I don't know, a lot of metrics that you can analyze. Of course, if you are in fire, maybe you don't have the time to read the whole output. But it's something you want to have for whenever the problem happens, goes away, start reading that, because it will provide a lot of information. And again, iterate through all the solutions. Questions? Either I speak too much, nobody understands what I said, or you just want to run away.
The million-dollar question is,
sure.
After everything this, you're still having problems, then you keep yourself home.
No.
Because sometimes it's, yes, I tune this, I tune that, I try different options, and sometimes it is still, maybe it's because you are bad.
Yes, probably yes. As I said at the very beginning, I like to keep things simple. One of the common or most common mistakes that I found, and believe me, it's very, very common, is that, okay, our application is slow. We are using AWS. Okay, buy a bigger instance. So you go from 16 CPU to 48. Wow, it works well until you increase your load. And then you see, there is a point where you cannot scale in hardware. So you have to take care of what's going on under the hood. You have to know your application. You have to know your environment. Sometimes, yes, you are at the very limit. So maybe you need to refactor your application. Sharding or splitting load. During this whole conference we had several talks about proxy SQL. Use master and slaves. Put the reads on slaves. Offload some work from master. If that doesn't work, okay, sharding. There is always a solution. If you think about it, Facebook runs on MySQL, so it's powerful. Sometimes, yes, we are the problem. Ask someone else. It happens to me all the time. I know nothing. Actually, I have good mates. They know a lot, so they help me. But no, for real. The thing is that you have to understand what's going on. With the time, I've been here for, say, over 10 years now. So it's more easy for us to find patterns. We attend maybe 200 customers. So we know every type of application now. So we may know, or we have some tricks now to understand where to tune. But sometimes you are overtuning, like I said with the I/O capacity variables. If you put that too much pressure there, and you run PT MySQL summary, and it says that you have 200 gigabyte buffer pool and 0% is dirty. Means that all the buffer pool is in disk already. Why you want that? It's not bad to have some dirty pages there, and, here and there, and it will save storage. I/O operations, and I/O operations are super expensive for MySQL. So maybe the problem is that you are overtuning things. That happens. Increase memory. Oh, key buffer size 2 gigabytes, only 200 megs in my SM tables. Why you want to waste memory there? That happens. Believe me. The per-thread buffers is a very common problem. Just suddenly, you have, I will put some number here. You have 100 megs of RAM or something, and you put 62 buffer, but suddenly everything starts to swap. Why? And you find that someone tuned the sole buffer size to 1 gig. Means 1 gig per thread. That's insane and happens. But yes, now don't shoot yourself. Life is good.
I will.
Go Percona.
Any question? Yeah, you can call Percona. Yeah, that's a good idea. He will work for us. Okay, if no more questions, I will be around there. Otherwise, thank you very much.